Hello and welcome back to Beyond the Basics, the series where we take Airfix kits beyond standard assembly and focus on precision fit, structural accuracy and refined finishing techniques. In this series we are building the Airfix 1/24 scale Supermarine Spitfire Mk IXc in the distinctive flying Dray configuration. This version represents an aircraft adapted after the D-Day landings to deliver beer barrels to forward troops. To reproduce this unusual role, the kit includes several unique components in addition to the standard Spitfire structure. These include a resin slipper tank, resin bomb racks with associated fittings, and resin barrels with separate end caps. The streamlined fairings fitted to the front of the barrels are believed to be modified P-51 Mustang drop tanks, intended to reduce drag in flight. This kit also includes pre-cut canopy masks, which are a very welcome addition during the finishing stages. Also included in each order of this kit is a Flying Dray pint glass. We will install all of the Flying Dray equipment later in the build. Because this is a large and highly detailed kit, the project will be divided into several episodes. In part 1 we will complete the entire cockpit and fuselage interior up to the point where the fuselage halves can be joined and aligned. Later parts will cover the wing, armament, flying surfaces and finally the Flying Dray external equipment. Before starting assembly, it's important to understand how this model is engineered. The Spitfire cockpit forms a structural tube that determines the alignment of the fuselage halves and ultimately the fit of the wing. If this cockpit structure sits even slightly too low or misaligned, it will cause problems later, particularly with wing fit and fuselage closure. This kit is engineered with very tight tolerances. Fit issues that some builders encounter are usually caused by two factors: either minor misalignment during cockpit assembly, or paint thickness accumulating on mating surfaces. Paint films may seem insignificant, but in a tightly engineered model they can prevent parts seating fully. The key to success with this kit is therefore simple: careful preparation, clean mating surfaces, and repeated dry fitting before glue is applied. When built accurately, the model fits exceptionally well. The primary structural elements of the cockpit are the side frames, bearers and bulkheads. These parts form the load-bearing tube inside the fuselage. After removing the parts from the sprues, all edges should be cleaned thoroughly. Any seam lines or sprue remnants must be removed so that every contact surface is smooth and flat. It's also beneficial to lightly chamfer the hidden edges of the cockpit frames. These edges are not visible once installed, and the slight bevel helps the parts settle fully into their locating grooves. This improves alignment and reduces the chance of interference during fuselage closure. To prevent paint interfering with fit, it is helpful to mask the locating grooves and structural contact areas before painting. This avoids the need to scrape paint away later and keeps joints clean and precise. The smaller lower bearers are less critical structurally, but still require proper cleanup and alignment during assembly. At this stage, the cockpit framework can be dry assembled to confirm the basic structure aligns correctly inside the fuselage halves. The first bulkhead can now be glued into the cockpit floor assembly. When positioning this bulkhead, it's good practice to temporarily place the fuselage sides around the structure to confirm alignment before applying adhesive. The pivot support for the rudder pedals can also be installed at this stage. Another bulkhead carries the rudder bar. The locating holes for this part are quite tight, and once painted they can scrape paint from the rudder bar shaft. Lightly drilling these holes improves fit and prevents damage to painted surfaces. Additional side structural pieces can be fitted into the cockpit frames. These parts are very precise and may even hold securely without glue, but adhesive can be applied once alignment is confirmed. The goal at this point is to assemble all structural cockpit elements that share the same base colour so they can be primed and painted together. The cockpit structural components can now be primed. A dark primer such as black works well as it naturally preserves shadow in recessed areas. Several small details require metallic or brass coloured finishes. These include pipework and priming pump details. Painting these first, then masking them before applying cockpit green simplifies the painting sequence and keeps colour boundaries clean. The rear cockpit sections and certain framework areas are silver rather than green, so these should be painted separately before final masking and colour application. The instrument panel should also be painted black and given a gloss coat in preparation for decals. The glossy surface allows the very small dial decals to be positioned accurately. Before painting the cockpit interior colour, small equipment units mounted to the cockpit sidewalls should be installed. These include environmental or defrosting equipment and emergency systems. Fitting these parts before painting avoids glue marks on finished surfaces and allows them to be painted in place for a more integrated appearance. Once installed, the cockpit structure can receive its cockpit green finish. Applying this as a light, controlled coat preserves subtle shadow and depth in the structure beneath. With the cockpit framework painted, the rudder pedal assembly can be installed through the previously prepared pivot holes. Because the holes were opened slightly earlier, the pedals should slide into place cleanly without damaging paint. The retaining crosspiece can then be installed above the pedals, securing the assembly without excessive force or adhesive. At this stage, repeated dry fitting of the cockpit into the fuselage halves is recommended. Confirm that the upper fuselage closes cleanly and that no gaps appear along the spine. The instrument panel carries a large number of very small decals representing the cockpit instruments. These should be applied carefully over the gloss surface and allowed to settle fully before sealing with a semi-gloss or satin clear coat. Once complete, the instrument panel can be installed into the cockpit structure. Proper seating here is essential, as misalignment can create gaps along the upper fuselage join. The undercarriage control assembly can now be painted and installed. This unit contains multiple colours including cockpit green, black and brass or copper pipework. After painting and decaling, the assembly can be inserted into its locating points within the cockpit. Another full dry fit of the cockpit inside the fuselage halves should confirm that the upper fuselage closes cleanly with no interference. Attention now turns to the pilot seat assembly. The seat frame side and rear structure are assembled around the seat shell. The Spitfire seat was made from a resin bonded composite material, so it should be painted a reddish brown tone rather than metal. After painting, a gloss coat prepares the seat for decal or belt installation. The kit seat belts, although slightly thick, look convincing once installed and visible from above. The armour plate is fitted to the rear of the seat, and the completed seat assembly is then mounted to its cockpit bulkhead attachment points. Care should be taken during installation as the fit is tight. A small voltage regulator unit is assembled and installed onto the seat structure to complete the rear cockpit assembly. Installing the seat assembly into the cockpit tube, all mating edges should again be checked to ensure they are free of paint and lightly sanded if necessary. The seat module should slide into the cockpit frame snugly and squarely. Once the alignment is confirmed, it can be glued into place. The remaining rear bulkheads can now be installed. One bulkhead has clear locating features and will naturally align correctly. The other must be positioned carefully and checked visually from the rear to ensure it sits square within the fuselage. With both bulkheads installed, the fuselage halves should again be test fitted. The nose and spine should close cleanly with no gaps, confirming that the cockpit structure is correctly aligned. Additional rear cockpit braces and antenna mounting structures can now be installed and painted silver. The shoulder harness should be threaded through the slot in the rear bulkhead. The belt ends may require a slight thinning to pass cleanly through the slot. Once fitted, the belts sit naturally and convincingly within the cockpit. Finally, the control column assembly is constructed from its painted components. The two-part design allows the grip wiring and details to be painted separately before final assembly. At this stage, the cockpit and fuselage interior structure are fully assembled, aligned and detailed. The fuselage halves close cleanly, confirming that the cockpit tube geometry is correct. And this completes part 1 of our Beyond the Basics Spitfire Mk IXc flying Dray build. In the next episode, we will move on to the wing structure, armament installation and external airframe preparation. Make sure you're subscribed to the YouTube channel so you don't miss the next part. We'll see you next time. We move from the completed fuselage to the more involved stage of building the wings. At first glance, the wing halves look straightforward, but inside they contain spars, ribs, gun bays, ducting, radiators, and the geometry that sets the aircraft stance. Getting this structure right now ensures the wing roots fit cleanly and the model sits correctly on its undercarriage later. The first task is preparing the undercarriage sockets in the main spar. These sockets hold the landing gear legs and must be installed before any other wing parts. Clean the spar carefully and test fit the sockets. They are handed and only fit one way, but are often too tight at first. Gently open the holes with a matching drill bit and smooth them with a round file until the legs slide in and out with slight resistance. This adjustment cannot be done once the wing is closed, so taking time here prevents major problems later. The small brace links on the undercarriage legs are assembled next. These parts need to be fitted now because access will be blocked once the wing structure is complete. The links glue to the legs only and not to the spar. After they dry, remove the legs and store them safely. Because the sockets were prepared earlier, the legs can now be inserted or removed at any time during the rest of the build, which protects the model during handling and painting. Wing constructions begins with the internal spars. 2 smaller spars are fitted into the lower wing half, followed by drilling out the gun barrel openings if the guns will be displayed. The main spar is installed in stages. We glue one side first and let it set fully, then flex the spar down to meet the opposite side and glue that. The spar tips must touch both wing ends, as this establishes the correct upward angle. Doing this correctly ensures the wing roots meet the fuselage cleanly when joined. The gun bay framework is then assembled. The cannon rib unit is built as a sub-assembly with its heater duct and mounted onto the spar. Ribs and ducting for the Browning machine guns are added next, followed by an infill plate and the ammunition tray. The ammunition boxes themselves are left off for easier painting later. Gun mounting brackets can be fixed now, so their positions are set before wing is closed. Interior painting follows. The undercarriage bays are finished in medium sea grey to match the aircraft underside. The gun bays and brackets are painted silver or aluminium. The guns receive a dark steel black finish with subtle metallic highlights, and the ammunition belts are painted in brass and steel tones. If only one wing will display open gun bays, the covers on the opposite wing can be glued on at this stage to avoid glue markings after painting. Once paint is cured, the guns and belts are installed. The cannon slides into its mounts, and the Browning guns clip into place. The cannon drum magazine is left off for now, as it would obstruct access during upper wing fitting and later painting. The wing can now be joined to the fuselage. If the fuselage interior was aligned correctly in episode 1, the fit should be straightforward. Glue the rear wing root joint first with thin cement and allow it to set. Next, secure the central joint to the cockpit floor. Finally, glue the intake scoop root and the front leading edge root joints with super glue, as these points carry slight tension from the wing angle. Working in this sequence prevents gaps and keeps the wings aligned. Upper wing panels are then attached. These panels have broad contact areas but little positive location at the root, so alignment is adjusted while gluing around the edges. Access through the wheel wells and radiator openings allow fine positioning. The panels are designed to overlap the wings slightly at the root, so a very small raised edge is correct. Once clamped and dry, the wing roots should appear smooth with minimal seam work. The remaining wing details are completed next. Radiator housings are assembled, the interior is painted silver, and the flaps set closed for a flush appearance. Internal pipework is fitted before the radiators are attached beneath the wing. Because the undercarriage legs were prepared earlier, they can now be inserted temporarily so the model stands safely during handling and painting. The wingtips are assembled and attached, checking alignment along the edges. The ailerons are built and fitted next. Although they can move, they tend to droop on both sides, which is unrealistic, so fixing them in place gives a more accurate look. Cannon barrels are assembled and installed at the same time. With all components attached, the wing is refined by scraping and sanding the leading edges, trailing edges, and tips until smooth. Small inserts near the wing roots are adjusted so they fit cleanly, but remain removable for later engine work. At this stage, the wing assembly of the Airfix 124 Spitfire Mk IXc is complete. The structure is aligned, the armament is installed, and the wing blended cleanly into the fuselage. This stage focuses on building the aircraft's power plant, the legendary Rolls-Royce Merlin engine that powered many versions of the Spitfire during the Second World War. The kit allows two different approaches. If you plan to display the aircraft fully closed up with the cowling panels fitted, you can build a simplified engine core that simply supports the propeller and the external panels. In this build we take the more detailed route and construct the full engine so it can be displayed with the cowlings removed. The process begins with the central core of the engine. Two main halves from the base of the block along with the lower sump. Once these parts are glued together, they create the structural foundation of the Merlin. The aim at this stage is to add as many parts as possible that will share the same paint colour. Around 80% of the engine will eventually be painted black, so assembling these pieces first makes painting much easier later. Next come the cylinder banks. The Merlin is a V12 engine, meaning it has 12 cylinders arranged in two banks of 6. Each bank is assembled and fitted to either side of the main engine block. Smaller valve components are added at this stage as well, and with those in place the basic form of the engine begins to appear. Another small assembly is created and attached to the top of the engine block, completing what modellers often refer to as the short motor, essentially the basic engine structure before additional systems are installed. Some parts that will eventually connect to the coolant system are included in the instructions at this point, but these are best left until later to make painting easier. Attention then shifts to the front section of the engine. A two-piece unit is assembled and attached to the top of the engine where it locks into position. The glycol tank and the front of the crankcase are assembled next, but these parts are left separate for now because they will be painted in different colours. The propeller shaft is installed into the front of the engine, and if you want the propeller to rotate once the model is complete, the shaft should not be glued in place. Leaving it free allows the finished propeller to spin. With the front section prepared, the earlier connected pieces can now be installed. These small parts slot into grooves on either side of the engine and align with the coolant tank. They can shift slightly while the glue is still soft, so it's best to position them carefully and allow them to dry before continuing. Several small assemblies are built next, forming parts of the supercharger system and the intake components. These are combined into a single unit and attached to the side of the engine. Additional pipework and fittings are added around the supercharger, gradually filling out the complex shape of the Merlin. At this stage, most of the components still share the same colour scheme, apart from the propeller shaft, which can be painted silver if visible, and nearly everything is finished in black. Once the major parts are assembled, the entire engine block can be painted in one pass, giving a consistent finish. After the paint has dried, some of the smaller components that were left separate earlier can be added. Magneto units sit on either side of the engine and are finished in slightly different colours to add visual contrast. Another set of parts representing ignition leads or wiring is assembled and attached to the side of the engine. These can be painted separately before installation for a cleaner result. The fuel pump assembly is also constructed and attached to the engine, and with this final piece installed, the main engine assembly is effectively complete. At this point, the entire unit can be painted black if it has not been done already. Even though most of the engine is black, subtle detailing can bring it to life. Adding a small touch of metallic paint to exposed bolt heads can highlight the mechanical detail. Some modelers also use graphite from a pencil to lightly brush across the rocker covers, giving them a slightly worn metallic sheen. With the engine itself finished, work begins on the bulkhead that sits behind it. Instead of installing it directly into the fuselage, it can be assembled separately first. Various brackets and small fittings are added, most of which are painted interior green. Building this section separately allows easier painting and detailing. Next come the engine mounts. These are the framework that supports the Merlin inside the Spitfire's nose. Two side frames and a central brace are assembled. The engine itself can be used as a guide to make sure these mounts line up correctly. By temporarily positioning the mounts on the engine while the glue dries, the framework naturally settles into the correct alignment. Before installation, several sections of pipework are painted and prepared. These pipes run through the engine mount framework and connect to different systems around the engine. One of the pipes fits fairly easily, while another must be threaded through the frame carefully. Some builders may choose to snip a small section of the frame to allow the pipe to slide into position without damaging the surrounding paint. Once the pipes are secured, the final bracket is attached and the engine is ready to be installed into the frame. Before fitting it into place, it's important to remove paint from the mounting positions so the glue bonds properly. The engine is then carefully manoeuvred into position, with the pipework aligning with the coolant tank at the front. The bulkhead can now be test fitted behind the engine. A little adjustment may be needed to ensure it sits flush against the fuselage structure. Some holes may also need to be slightly widened so the pipes can pass through without stress. At this point, the engine assembly is sealed with a coat of satin varnish to unify the finish. Light weathering can be added to suggest heat and wear, especially around the copper pipework. Little graphite or metallic pigment helps give the impression of burnt metal and working machinery. Several additional components are built to complete the front section of the aircraft. A small silver painted unit is assembled along with the air scoop beneath the engine. Side frames and the front section are also constructed and painted before being attached to the engine framework. The exhaust stacks are assembled next. Each stack is made from two small parts that are glued together and painted before installation. They fit snugly into place and often don't require glue. Once installed, the exhaust can be weathered using a mix of colours and metallic pigments to create the appearance of heat-stained metal. With the exhaust fitted and the framework in place, the engine assembly is essentially complete. A final test fit inside the fuselage ensures everything sits correctly. If the engine mounts and structures were aligned properly during the build, the removable cowling panels should also fit neatly over the top. With the Merlin now fully assembled and detailed, the next step will be completing the surrounding frames and cooling system before finishing the propeller and spinner, bringing the entire front section of the Spitfire together. In this final stage, we will complete the model by painting the camouflage, adding the invasion stripes, applying decals, weathering the aircraft, and finishing the assembly with the undercarriage canopy and final details. To make painting easier, the removable cowlings have been temporarily taped together from the inside and then taped to the fuselage. The tape holds the parts surprisingly securely, and the lower cowling also helps keep everything aligned. This allows the entire airframe to be painted as a single piece, so the camouflage pattern flows cleanly across all of the panels. The lower cowling will eventually be painted separately, but for now it stays attached so the pattern matches correctly. Before any paint is applied, the openings need to be masked to prevent overspray. The cockpit opening, gun ports, aerial mounting point, and any exposed interior areas are carefully covered so paint cannot enter the model. The first layer applied to the aircraft is a full black base coat. The entire airframe is sprayed black, which helps reveal the subtle stress skin detail moulded into the surface of the model. The light rippling effect of the aluminium panels becomes much more visible under this coat and adds realism to the finished aircraft. The black base also provides a dark tonal foundation that will influence the colours that are applied later. Once the base coat has dried, attention turns to areas where the paint would naturally wear. Before the camouflage colours are applied, selected panels receive a layer of silver paint, followed by chipping fluid. This is only applied in the areas that would realistically see wear, such as leading edges, high traffic panels, and places where ground crews would frequently step during maintenance. Applying it selectively helps control the final weathering so the entire model does not appear overly worn. With the base layers prepared, a light silver underpainting layer is sprayed in certain areas to help break up the large blocks of colour that will come later. This subtle tonal variation adds depth beneath the final camouflage. The camouflage layout is then lightly drawn onto the surface using pencil lines to guide the pattern. These lines show where the RAF camouflage colours will fall across the wings and fuselage. The camouflage is painted first and the invasion stripes will be added afterwards. The first camouflage colour applied is the dark green upper surface colour. It's sprayed freehand along the pencil guidelines to establish the pattern. On camera, the contrast between the colours can appear quite strong, but in reality the effect is more subtle and can be softened later if necessary. Once the green has been applied, the camouflage boundaries are masked before the grey colour is sprayed. Small rolls of blue tack are placed along the pencil lines and supported with masking tape. The blue tack creates a slightly raised edge, which produces the soft but controlled camouflage line that is characteristic of RAF aircraft when the second colour is sprayed. With the masking in place, the grey camouflage colour is applied across the remaining upper surfaces. When the masking is removed, care must be taken around areas treated with chipping fluid, as the paint can sometimes lift more easily than expected. Once the camouflage paint is dried, the chipping fluid can be activated. A small amount of water is sprayed onto the surface and then gently worked with a stiff brush. This softens the paint layer and allows small chips to appear, revealing the silver beneath. The aim is to create subtle signs of wear rather than heavy damage. With the camouflage complete, attention turns to one of the most recognisable features of the aircraft, the D-Day invasion stripes. These markings covered large sections of the wings and fuselage and were usually applied quickly in the field. As a result, they were rarely neat or perfectly straight and often showed heavy wear, particularly on the upper wings where ground crews frequently walked. The spacing of each stripe is around 19.5mm, and if the first stripe is even slightly misaligned, the entire pattern begins to drift out of position relative to panel lines and other details. The area is first sprayed completely white, and once the paint is dried, the black stripes are carefully masked and sprayed over the top. The upper wing stripes are weathered more heavily to represent the wear caused by foot traffic, while the underside stripes are kept much cleaner since they would see far less use. Masking the underside stripes is slightly more complicated because the pattern needs to wrap around the radiator housings and air intake structures. Rather than attempting to mask the entire underside at once, the painting is carried out in sections. The underside is first sprayed white before the black stripes are masked and applied. Once the stripes are complete, the paintwork is sealed with several coats of semi-gloss lacquer. This protects the paint and prepares the surface for decals. A full gloss finish is not necessary, as the semi-gloss surface is already smooth enough for the decals to settle properly. The decals are then applied. The decals respond very well and require only a small amount of setting solution. Setting solution is applied to the surface before the decal is positioned and excess moisture is removed with a cotton bud. Gentle heat from a hairdryer helps the decals settle down into the panel lines and rivets, so it appears painted onto the surface. With the major paintwork completed, the next stage is fitting the flaps. On the real Spitfire, the flaps were not adjustable for a range of positions. They were either fully raised or fully lowered, and were mainly used as air brakes rather than lift devices. In reality, they were rarely left down on the ground because they restricted airflow through the radiators. For display purposes, however, they are installed in the lowered position. Before gluing them in place, any paint is removed from the contact points so the glue can bond properly. The flaps are then secured in position using superglue so they sit at roughly 90 degrees. The landing gear assembly begins with the wheels. Each wheel is made up of 2 tyre halves and a 2-part hub assembly. The hubs are painted silver and the tyres are painted in a tyre black colour. A small alignment key on the hubs is removed so the tyres can sit correctly on their flattened sections. The bottle is placed on the flat surface while the wheels are assembled so the flat spots naturally align with the ground. Once positioned correctly, the wheels are pressed onto the hubs and the landing gear legs are permanently glued into their wings. With the undercarriage installed, the remaining small details can be added. These include the radio antenna mask, the flat position indicators, and several small access panels. The engine is also permanently secured by gluing the mounts and bulkhead and engine bearers, which allows the surrounding panels and infill sections to be fitted. A slipper fuel tank is then installed beneath the fuselage. This tank mounts in a way that traps the lower cowling in place, so the cowling must be glued permanently before the tank is attached. The entire model then receives a satin clear coat, followed by a final matte finish. The matte coat helps unify the paintwork and provides a better surface for weathering powders and staining effects. Weathering is applied gradually across the aircraft. Gunport staining is added using smoke effects to simulate cordite residue from the cannons, and exhaust streaking is applied along the fuselage sides using weathering powders. These stains usually show a darker soot centre surrounded by a lighter outer residue caused by the leaded fuel used during the period. Small fuel spills are also added around the filler caps, and a light dusting is applied across the decals to tone down their brightness so they blend naturally into the surrounding paint. The canopy assembly is then prepared. The canopy is made up of the rear section, the windscreen and the sliding hood. One version of the canopy includes a faint mould seam running down the centre, which must be removed. The seam is carefully sanded using very fine abrasive pads before the clear plastic is polished using polishing compound until it becomes perfectly transparent again. The canopy frames are masked using the pre-cut mask set included in the kit. The interior frame colour is sprayed first, followed by the exterior camouflage colours, so the framing appears accurate when viewed from both inside and outside the cockpit. Before the windscreen is installed, the gun sight assembly is built and placed into position in the cockpit. The windscreen and rear canopy sections are then glued in place using small amounts of extra thin cement applied carefully along the edges. The sliding canopy can either be left loose or secured with a clear adhesive designed for transparent parts. The cockpit side door is installed in the open position. Finally, the aircraft receives its most unusual addition. This particular Spitfire is equipped with beer barrels mounted beneath the wings. The barrels are cast in resin and must be carefully removed from their casting blocks. Resin is brittle and produces fine dust when sanded, so it's important to work slowly and carefully while cleaning the parts. Each barrel consists of the main body, end caps, nose cones and mounting brackets. Once cleaned up, they are assembled, painted and decaled before being attached to the aircraft. The mounting brackets are extremely delicate, so they must be handled carefully during installation. With the barrel secured beneath the wings and the slipper tank installed under the fuselage, the model is finally complete. This has been a detailed and rewarding project with a lot of painting, masking and careful assembly, but the finished Airfix 24th scale Spitfire Mk IXc captures an enormous amount of detail and character at this scale. Thank you for following along throughout this series and joining us for the full build. We hope you've enjoyed, and we'll see you next time.